Hello everyone. So in this video we'll start talking about pushdown automata, and just as corresponding to a regular language I had deterministic automata, corresponding to context-free languages I'm going to have pushdown automata, and which means that I can draw a pushdown automaton for any context-free grammar that's given to me. So, as always, we'll start off with trying to intuitively understand what a pushdown automaton is, and in subsequent videos, we'll look at the formal definition of pushdown automata. So, uh, pushdown automata are something like this. There is a finite automaton here. So, I have my NFA or DFA here, and along with that, I'm also given a stack. So this is a stack right here. And what I can do is whenever I see an input symbol, I can change state, and I can also push or pop something from the stack. So that does give me some additional power, and we'll see how. So till now what we've been doing is we just did a transition from a state q on input symbol A, we went to some state q prime. What we can additionally do in pushdown automata is we can look at what state we are in, what input symbol we've got, and we can look at the top of the stack. So if my stack has these elements right here, I can look at the top element in the stack, and based on all of these I can decide which is the new state that I want to move to. And additionally what I can do is I can also change the top of my stack to some x prime. So this is something that I can do, and let's look at how a transition in a pushdown automaton is written. So I have, let's say, q0, which is my start state, and I'm not drawing an entire pushdown automaton, I'm just trying to show how a transition is written. So from q0 I want to move to q1, and what does this when do I make this transition? When I have an input symbol, let's say A, and additionally what I can do is I can specify what the top of my stack is and what the new top of my stack should be. So the way we often write this is, in this case the top of my stack is probably going to be epsilon because the stack will be empty, and from there we could say that we are going to sum A. So what this transition shows is that I'm when I get an A as my first input, this is my let's say this is my string right here, then I'm saying that my first input is A, and additionally I'm trying to check whether the top of my stack is epsilon. Yes, it is. In that case, move to state q1 and change the stack to something like this. My stack will now have a capital A at the bottom. So that's how a transition in a pushdown automaton is written, and we'll look at a formal definition in the next video, and after that we'll look at an actual pushdown automaton. But what I want to mention here is, let's consider this language itself, this string itself, which actually belongs to our popular language, which is a to the power n b to the power n. If we wanted to draw a pushdown automaton for this language, what we would do is we would just stay on some state q1 till I'm getting A's, and what I do is whenever I get an A, I push an A onto the stack, and whenever I get a B, I pop an A from the stack. And at the end of the string, when the string ends, when I reach right here, if my stack is empty, then I can say that the string needs to be accepted. So I hope you have an intuitive understanding of how I can draw a pushdown automaton for this, and I'm going to be able to draw a pushdown automaton for any context-free grammar that's given to me. And one last thing before we end this video, if we consider regular languages, we know that every regular language is definitely context free, which means that we should be able to draw a pushdown automaton for any regular language that's given to me. And what we do in that case is we just disregard this stack altogether. So we disregard this part altogether. If it's a regular language, I don't need to push anything onto the stack. I don't need to pop anything from the stack. I don't need to look at the stack at all. I just look at my finite automaton, which is this part right here, and with that itself I can draw a DFA or an NFA for my regular language, and of course that's also a valid pushdown automaton. So that's the last thing I wanted to mention. In the next video we'll look at the formal definition of a pushdown automaton. I'll see you in that video. In the meanwhile, don't forget to give this video a thumbs up, share the video with your friends, and if you haven't already, subscribe to my channel. I'll see you in the next video.